Welcome to the Amp Lab and Tools of the Trade, where I show you the test equipment of an electronic technician specializing in servicing music gear and how I use it. I'm Amp Tech Ron, and today we'll look at my Tektronix CFG 250 signal generator. I use it primarily as a source signal to inject into the front end of amps and effects when I'm signal tracing them. And it has a few other cool uses too. And coupled with an oscilloscope, it's an absolutely essential piece of gear for the electronic technician. So let's take a look at something that every technician has on their bench. On a serious note, if you don't know what you're doing, please don't work in a high voltage environment. It can only end badly. Paired with an oscilloscope, a signal generator is one of the most essential pieces of test gear that you'll ever have. You can't really do it without it. It's primarily used to inject a signal into the front end of amplifiers and effects we're working on, and then we signal trace using the probes, oscilloscope probes, to see if there's any breaks in the signals or distortion or whatever. I'm going to cover signal tracing at a later video, but essentially that's how we do it. Most amps and everything are rated at 1 kilohertz signal for all that stuff, so I think probably most techs use that signal to test most of their stuff. If you have low frequency, high frequency issues, you might want to change it up a little bit, but usually that's where I have it. You can adjust the frequency on it, see, higher or lower frequency, whatever. But like I said, I keep it on about 1 kilohertz. Seems to work for most stuff, and unless I spec some kind of frequency specific issue. One of the other purposes I use the signal generator for is for running square waves. As you can see here on the screen, they're square. What I use this for is to see if there's any kind of exaggerated frequency response, usually in the treble, sometimes in the bass. And how we'll see that is, if you'll see here the very leading edge, we call it here the tip of the square wave, if we have an exaggerated treble response, this will kind of spike up and not look even. See if I can simulate it here with the EQ. Well, there we go. See, as it starts going up, just turn into treble control there. I have these adjusted to be square. And at the same time, the other end is the bass response. And it'll start sagging or everything if that's not right. So when I want to test out an amp, with these the spectrum analyzer and everything, I'll usually set all the frequency controls so it most approximates this square wave. It tells me it's neither really boosting or cutting any frequencies, and I can get an accurate analysis of the response of the amp. I've seen tube issues and things like that that'll cut the bass frequencies, and you'll have nothing but a high-end response. You'll still hear audio, but it sounds like crap. And that's one of the uses of this kind of thing. And I don't use it often, but when you want to check things out, it's a good thing, and it's very valuable if you're coming up with circuits and you want to see how they respond, because you want them to be able to accurately be able to recreate what you put into them, and this is really a difficult test for most amplifiers. Alright everybody, I'm going to show you the final use of the signal generator that I don't use often, but it's a very valuable tool. If you suspect that you may have a defective speaker, sometimes for various reasons the cones will start rubbing and making weird sounds, and they may be hard to track and everything. But an easy way to check these things is I take my signal generator, I just run it into a little bench amplifier I have here, an old PV solid state amp, and I run it into the speaker, and I go from the low frequencies up to the high. I'll sweep them with the frequency knob, and at any point if I hear any kind of strange distortion or rubbing noises or whatever, I'll know that that speaker's bad. And if you've ever reconed speakers, you have to do this too after you recone them, and I'm telling you that is way harder than it looks. I've done a bunch. I've messed up a bunch, and that's not fun when the kit costs 50 to 70 bucks. So I'll do that no more. I'll leave that for more dexterous people. But this is how I check out a speaker. I got just a cheap Fender 12-inch speaker over here in the cabinet, and I'm going to run the signal generator through it, starting at about 20 hertz and coming up. You should hear it. Just a puttering noise. Ten hertz. Let's go to 100. Here's about 20, 40. 200. 1,000. 2,000. Going over 10, 15K there and can't really hear it anymore. That's the response of a good speaker. If we heard any kind of distortions or things like that, they'll show up and you can dial into it and it becomes really apparent. It can be a really aggravating part of your tone if you hear that, if you have a 4x12 or whatever and you have to pull them out and test them individually like this. But something this thing does really well. And like I said, this is a 5 out of 5 on your essential scale as an electronic technician. Got to have with an oscilloscope. It does the other things too. Can't live without it. You can probably get away with generating a tone on a computer and plugging it in the front amp, but won't do this. These aren't expensive, 50 to 100 bucks. Go get one. I'm Amp Tech Ron, and thanks for joining me in the Amp Lab. And I'll see you on the very next Tools of the Trade.